So in this video, we are going to be looking at the different representations of direct variation. So symbolically, direct variation, y equals kx. For the example here with a car driving 25 miles an hour, that's going to be y equals 25x. If you're using the distance formula, d equals, or distance equals rate times time, that would be d equals 25 for the rate, t for time, in this case hours. So that's symbolically or algebraically or as an equation. Direct variations can look like this. On a table, could look like this. 1 hour, you've driven 25 miles, 2 hours, 15 miles, so on and so forth there. We can also look at this same scenario on a graph. There's the 1 hour is 25 miles, 2 hours, 50 miles, 0 hours, 0 miles. We can also look at these in words. You're driving at 25 miles an hour. So in this video, that's what we're going to be looking at, the different representations for direct variation, and then also going back and forth between the different representations. Let's go ahead and nail down some of the vocabulary we're going to be using in this video here. So again, direct variation, it's going to take the form algebraically, y equals kx, and then that k right here, that's going to be your constant of variation, or the variation constant. So the x and the y, those are going to remain variables, and then we're going to have a constant here for the k. Now again, the y and the x, those are variables. Those are your values for your inputs, your outputs, your independent, your dependent type variables there. Now, all of the direct variations, their graphs are going to go right through the middle, the origin 0, 0, shown here as an example. Now, when the k is positive or greater than 0, it's going to look like this. And anytime you see kind of these inequalities here, try and translate them back into English. So greater than 0, well, that's the positive numbers. Now, if k is less than 0, well, less than 0, those are going to be negative numbers. So if that k right there is a negative number, then from left to right, the graph is going to decrease. If k is positive, it's going to increase there. So this k can be any value. It can be an integer, a fraction, or a decimal. Now, in previous classes, we may have looked at these same types of relationships, but they may have been called a proportional relationship. Y equals mx, and the m there is basically said to be like the slope or the rate of that function here. So we're basically taking this same idea, but it's going to have different vocabulary attached to it. So here we go. The cost C for F number of flowers shown in the table below right here. We're going to go ahead and graph this relationship, and we do know that it's going to vary directly. It says so right there, but in this case here, we can infer that it's a direct variation because 0 flowers will cost $0. So here we go, 0 flowers, $0. That kind of makes sense with the scenario here. Now, if you got to buy a vase with it or something like that, well, that might be a different story and a different type of relationship. Now, we can take any of these values here. 5 goes to $23.50, 5, and then just above 20 for $23.50. 10 flowers goes to $47, 10 flowers, 47. Going to be kind of in between the 40 and the 60, a little bit closer to 40. 15 flowers goes to $70.50, 15 to $70, give or take right in between the 80 and the 60. 20 goes to 94, so 20 flowers, 94, going to be almost 100 there. And then 25 flowers goes to $117. 25 flowers, 117, almost to the 120 there for the cost. Now, if we're doing this by hand, we are going to want to choose the 0, 0 for sure, and then kind of the number that's farthest away. So this would be the best two values if you're doing it by hand. So if you estimate this 5 and then this was $23.50 and you're off by like a millimeter on your piece of paper, then it's going to kind of go off a little bit this direction here, you're going to be a lot less exact. So when we're graphing these by hand, we want to pick points that are far away from each other, but still convenient to use. So it would be best to use the 25 and then the 117 if you're graphing it by hand. If you're doing it like on a computer or something, most of the time it won't matter which 2 points. You'll pick 0, 0, and then any of these other ones here. Another example we'll look at is graph that we have the jeans are on sale at a store called Buckle, and they're $97 each. And so we're going to go ahead and graph this on the grid here. It does tell us in the directions it's a direct variation. It varies directly. In this case here, we kind of already know that. all these direct variations, they go through 0, 0, which makes sense. If you buy 0 jeans, it's going to be $0. Okay, now we need to find another point along here. So we don't have 1 on here because we know 1 pair of jeans costs $97, but there's no 1 on the grid here. So we can try 2. So 2 jeans, how much are those going to cost? Well, that's going to be $97 times 2 pair of jeans. So that's going to be $194. So you could do 100 times 2 is going to be 200, and then just graph right below the 200 on this, because again, you don't have an exact 194 on your grid, so you just know that this is going to be right under $200. So, and there's your graph there. Again, if we're graphing it by hand, we do want to go a little bit further to the right on the grid, so looking at 10 here, and this one's actually going to be a little bit easier to estimate or to calculate how much 10 jeans are going to cost, right? So we're going to do $97 times 10 pair of jeans. Oh, we'll just put a 0 behind the 7, and boom, there you go, 970. So now we go up here, 970 is going to be just under 1,000, so we go up here, and then just under 1,000, going to be about right there. And again, if we're graphing it by hand, the further away the points are, the more accurate it's going to be. And we can use any of these values up here. 4 pairs of jeans, that's 4 times 97. 6 is 6 times 97 goes there. You can use any of those points there to make this graph here. Again, we just want to pick simple ones to do and ones that make sense for our question. Obviously, we're not going to pick like 2,000 pairs of jeans because it's going to be way, 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 way out there. So we're back in a car driving here. We do know that it's told to us that we're going to have a direct variation. Varies directly means it's a direct variation. So we know off the bat, 0, 0 is going to be one of the points, which makes sense with this question here. If you're driving for 0 hours, you went 0 miles. Okay, but we have our equation here, d equals 57t. So this is going to be distance equals 57 times time. So in this case here, after 1 hour, how far will we have driven? Well, 57 miles. So boom, right above 50 there. So there's a good look at a graph there. Now, again, if we're graphing it by hand, we do want to pick points that are kind of far away. So 5 hours would be another good point to use if you're not going to use the one there. If you're on a computer, a lot of times you're going to be okay picking ones that are close together. But again, if you're off by just a slight millimeter up and then you go to graph this, it's going to get more and more off as you get further to the right on the graph. So picking points further away is going to be a little bit more helpful. So 5, that's going to be your input. So 5 goes in for T for time, 5 hours. So we're doing 57 times 5. And then our output is going to be the distance. This one, if you want to use a calculator, go ahead. If you're trying to do it in your head, another way of doing it is, well, 57 times 5 is kind of tricky, but 60 times 5, that's easy. It's going to be super close, right? So 60 times 5, well, that's 300. It's the same thing as 6 times 5, 30 with a 0 on the end. But we're going to be over by a little bit because we rounded the 57 up by 3. So we're over by 3 5s. So 3 times 5, that's going to be 15. So we just need to take 15 off of that. So that's going to be 285. But again, on a graph like this, even if we stuck with the 300 there, it's going to be just under 300. So for 5 hours, be just under 300. There's 300 there. Just under that is where our amount would be, even if we just rounded it here to 300. So there's another point there that we could fairly easily use. Now, we could have used any of these points on here. For 1 hour, 57 miles, 2 hours times 57 makes 114, 2, 114. 3 hours goes to 171 miles. 8 hours goes to 456. 8 hours, 456 would have been almost at the 450, just above it. So could have used any of these points here as well. Now, real quick, this D equals 57t, that is the distance formula, or dirt formula, as some people call it, kind of makes DRT, right? Distance equals rate times time, D equals RT. So it's a common direct variation equation that you'll see a bunch. We're going to go ahead and switch up a little bit. We're going to be working backwards and starting with a table and then writing an equation from the table. So remember our direct variation equations, y equals k times x. Now in this case here, remember k is that variation constant and it kind of has a slope or a rate type idea behind it. So again, that's slope or rate when we're thinking about the k. So here we go. first up, we need to calculate the rate or the variation constant or the constant of variation. And you can take, for direct variations only, you can take any of these points here, any of these 3 and 1296, 4 and 1728, 5 and 2160. You can take any of those. We'll just go ahead and take the top one real quick. And so that's going to basically be your dependent variable, the cost, 1296, divided by the independent variable. In this case, that's going to be a 3. So, and then how much, this one, not too difficult to do in our head. We can just start out 12 divided by 3. Well, that makes 4. And then we have the decimal point after that. And then 9 divided by 3. Well, that's going to make a 3. And then 6 divided by 3. That's going to make 2. So there's our rate or our constant of variation. Before you just go to a calculator, maybe take a half second and see if any of these are really quick to do in our brains. So our equation, that's going to be C. That's our dependent variable. C is the dependent variable. Always shows up on the right-hand column on a table, and that's going to equal. And in this case, next we have our K. That's our rate or constant of variation. We found that out here, 432. And then our independent variable, well, that's going to be B for pounds of blueberries. So there we go there. Now, another really easy one to use would have been the 10, right? So we're going to end up doing, to find our rate, our 432, we're just going to do 4320 divided by 10. Well, anytime you divide by 10, you just kind of move a decimal place over in this case here. So that would have been 4.32. Well, 4.32, there we go. So again, this is a direct variation. It doesn't necessarily say it in the question here, but if you know 0 pounds goes to $0, then you know direct variation, okay? The other thing too on any of these, sometimes the weight of your container, sometimes they charge you. It doesn't make sense on this question, but like we just want to make sure that the weight of the container or the vase or what, whatever else you're using, there's no like hidden, extra cost on there or a starting value. Okay, we're writing another direct variation. So varies directly means it's a direct variation. Now, from a graph to an equation, this is depending on how it is. Sometimes we have to estimate the graph, estimate the rate from the graph. So that's what we're going to start out with looking at there. And whenever we're trying to look for rate from a graph or slope or whatever, we're going to be looking for nice points. So in this case here, we start there. Oh, this is not a nice point here. 30 we know is the money earned, but we don't know how many hours it is. But over here at the 3 hours, we know exactly that's 3 hours, but we're not quite sure how much money is earned there. So we keep going up. No, that one won't work. So here's a nice point right there. So we know it's exactly 6 hours and $90 earned. And as we keep going up there, nope. So, there's another nice point there because we know exactly it goes through a vertical line and then it also goes through a horizontal line. That's what these nice points are. They're not really like mathematical terminology, but it's how I used to explain it. So here we go. We have 90 hours, or $90, and then we have 6 hours there. And then in order to find the rate from the graph there, we are going to divide. So this one, not super duper tricky to do on our head. Again, before you roll straight to a calculator, just see real quickly if you can do it mentally in your head. So remember, dividing by 6, so 90 divided by 6, that might be a little bit tricky. However, if we break it up into 2 smaller questions, well, that's not too tricky here. Dividing by 3 and dividing by 2 is the same thing as dividing by 6. So let's do that. Start at 90 and then divide by 3. Oh, well, 9 divided by 3 is 3 with a 0 on the end, so that's 30. And then 30 divided by 2, well, that's going to make 15. So this one, if we break it up, not too tricky to do in our head. So we're making $15 an hour. So our equation, D, now you can use the Y if you want for your dependent variable. I use D for dollars on this one. Sometimes like on the question that you're working on, it'll say, hey, you have to use D for dollars or C for cost or H for hours or whatever, or T for hours, T for time for hours. So just make sure you're using proper variables. I'm using D for dollars there instead of a Y for the dependent variable. And then we have the equal sign. Next up is our K. That's our variation constant or the rate. In this case, that was a 15. And then our independent variable is going to be the number of hours. So you could use X if you want. Up here it's an X, but H for hours, or you could use T for time in hours as well. So remember on this one, we know right off the bat, it's a direct variation because it goes through 0, 0. So this whole just pick a point and then just divide the two values only works if it goes through 0, 0. In other words, it is a direct variation. So later on in the year, as we get through more math, this isn't always going to be the case where you just pick a point and then divide to find your rate. All right, another example that fits the direct variation is, let's say that we're going to be cooking a meal and we're going to have some rice with it. Well, for every cup of rice that you cook, that's going to feed about 3 servings or 3 people there. So I did go ahead and make a table of this, make it a little bit easier to wrap our brains around what is going on here. So pretty obvious to know if you cook 0 cups of rice, you'll end up with 0 servings. 1 cup of rice goes with 3 servings shown there. 2 cups goes with 3 servings. 3 cups will feed 9 people, and so on there. So basically all we're doing is we're taking how many cups of rice we're using and multiplying it by 3, and that's going to give us how many servings. So again, in this case here, we're using Y for number of servings, or you could use an S or P for number of people. So the number of people is going to equal 3 times however many cups you're using. And again, that could be R for cups of rice or C for cups or whatever you want to use there. So because we already know that this 0 servings goes with 0 cups or vice versa, we know that that's going to be a direct variation. The number of servings varies directly with the number of cups of rice. This varies directly, has kind of a similar flavor to it as when we were talking about with functions. So the number of servings depends on the number of cups of rice being used. So there's some similar language in there, but this lesson, this video is mostly getting used to the direct variation vocabulary. Okay, taking a step off to the side here. So remember, here's our direct variation equation. We're going to be looking at more abstract ideas, not so much real world type activities. So y equals kx. Remember that k, that's your variation constant or constant of variation. So what happens if we solve for k? So get k by itself. So we have y equals kx. We want to get k by itself. So that right now we have k times x. We don't want the x next to the k. So we're going to unmultiply. K is being multiplied by x. So we're going to unmultiply. That's divide by x. So there we go. Divide by x to both sides. And so in this case here, y over x equals k times x divided by x is 1. So k times 1 is just k. So whenever we solve for k, or if we want to find the value for k, we're just going to take the dependent variable divided by the independent variable. So, and that's going to right away give us that variation constant, or the constant of variation. So example using that, here we go. So we know m varies directly as n. So write a direct variation equation when or if n equals 5 when m equals 19. So part of this lesson is just figuring out what the heck do these words mean. It's kind of a definitions and knowing your new vocabulary type stuff here. So this m varies directly as n. This kind of has that function type idea. M depends on n. So when you see the depends on, that means equals. So m equals n. Something n. You're going to have the m, then an equal sign, okay? And it's going to take the form m equals kn. Y equals kx is what we normally see. Okay, so now what we need to do is find that value for k. So remember from just before there, you basically take the dependent variable divided by the independent variable, and that's going to give you the value for k, the variation constant. Okay, so k equals, it says right up here, m is 19, so that's going to replace the m in the numerator, and then n is 5, so that's going to replace the value in the denominator. So there's your k, and it's really that easy. Now 5 doesn't divide into 19, so we're just going to leave it as a fraction. So remember, here's our answer over here. It's m equals k times n, and k was 19 over 5. Boom, done. So it really isn't meant to be super tricky. Now, if you remember this part here, k equals the dependent divided by the independent. Cool, it's going to go fast. But what happens if you don't have that memorized? You already know that this m varies directly as n means m equals kn. Well, dude, just write that down. There's our formula. Now, all you do is rewrite the formula with the values that you know, all right? It says right here, m is 19. This is an alternative way of figuring out the value for k, right? So the m is 19 and the n is going to be a 5, so just replace those there. So there we go. Now solve for k, right? So k is being multiplied by 5 here, so unmultiply it by 5, divide by 5, boom, boom. There we go. So now we have 19 over 15 there equals, and then 5 over 5, well, that's just 1, so you have k times 1 makes k. So this is just an alternative way of calculating the value for k, and there you go. There's where the 19 over 5 goes. go ahead and have you try this one out on your own. Pause the video, try it out, then come on back, see how you did. So we know that V varies directly as H. This is going to be V equals is what this part here, similar to the function notation vocabulary depends on. V depends on, right? So it would mean V equals K times H. We do have to find the value for K. So basically what we're going to do is just take the dependent variable divided by the independent variable, the V divided by H. So there we go. So K is going to equal, the V is 11. So V gets replaced with 11. And then the H is 13. So H gets replaced with 13. So now here we go. Back to, here's where our answer is going to go. V equals K times H. And K was 11/13. 13 doesn't divide into 11. So we're just going to leave it as a fraction. Again, if you forgot how to find the value for K, then you're basically just going to start with your formula, which you understood here, V equals K times H, right? And then replace for the values that you know. The V was 11, says so right there. The H, that's going to be 13, says right there. Now solve for K. We want to get K by itself. It's being multiplied by 13, so unmultiply by 13, aka divide by 13. Boom, divided by 13. So we have 11 over 13, doesn't divide in evenly, so that's 11/13. And then 13 over 13 is just 1. K times 1 is just K. And boom, there's your value for K there as well. So if you have this part memorized, how to calculate K, this is going to go a little bit faster. If you forgot it, it's been a couple of weeks, now you're taking the test, you can use this other idea here. Just write down your formula, write in, replace the variables with what they equal, and then solve. Another look at a direct variation. Here we go. Perimeter, which is going to be the variable y of a square, varies directly with its side length. In this case, it's going to be x. It's going to be the variable that stands for side lengths. Okay. So with any of these, like whenever you see the words there, try and rephrase it so that way it's a little bit easier to wrap your brain around. So this is the format that our answer is going to be in, right? Because it's a direct variation. Says so it's varies directly, direct variation. So here we go. We're going to rephrase it. Perimeter is, or how do you calculate it? You're going to take the four sides and you're going to multiply it times the length of each side, right? That's how you find perimeter. You're going all the way around the square, right? So four sides, four lengths. So here we go. So perimeter, remember that's going to be a y. So there's y. Is, in math, generally speaking, is an equal sign. Four sides, well, that one's pretty easy. It's 4, right? Times, well, that's times, right? And then L for X for length, right? So right here, length is going to be X. So there we go. So there's your answer right there. Y equals 4X. And that's how you find perimeter. Now, again, on some questions, they're going to say, no, you can't use Y's and X's. We want P for perimeter and L for length. So it could look like that as well. And this is the way we normally see it on like our formulas page. Anytime, we go to the, the front of our math book or something like that. Okay, so just quick wrap up here. So direct variations, y equals kx, right? K is the constant of variation or the variation constant. And that K there, that has a rate type idea assigned to it, okay? All of your direct variations go through the coordinate point 0, 0. You're going to also, if it doesn't tell you directly, like this is a direct variation, so right? So they're going to write in there varies directly. So these are two ways of finding direct variation. One, they say direct variation, or it goes through the origin, or they use the phrase varies directly. Then you know, hey, I have a direct variation. And then K, it can be an integer, a fraction, or a decimal. And then to calculate it, you're taking the dependent variables divided by the independent variables. So in the back of your notebook, if you've been keeping a formulas list there, y equals kx is direct variation. Boom, there you go. You could write something about the origin there if you want to. And then k equals y over x. So you want that in your formulas page. And then this also as well. Again, I recommend having a formulas page in the back of your notebook, like the last 5 to 10 pages, and you can just write them all in there. All right.